So in this section, we're going to be talking about the problem-solving method called dimensional analysis, and we've been using this process already, but it's worth just kind of formalizing what we mean by dimensional analysis. So dimensional analysis is a technique in which we track units through a mathematical operation in order to make certain that we've set the calculation up correctly, and also to be able to show to other people that we know what we're doing and that we've set things up correctly as well. So being able to express to others how you arrived at an answer is critically important in most technical fields. And similarly, having a problem-solving method that allows our errors to be rapidly detected can literally be the difference between life and death. And there are many examples where someone has made an error in a series of calculations, and as a result, someone has died. So, sometimes we think that we're too good, or it's unnecessary to illustrate what we're doing, but even the best guys use these kinds of methods. So even if you think about like the astronauts who are highly technical, some of them are the best in their fields, they've competed amongst thousands of other people to get to the positions that they have, they still use checklists, and you'll see in here there's a little bit of dimensional analysis going on, and dimensional analysis in order to make sure things don't go wrong. So dimensional analysis is a technique in which we use the units to help confirm we've set up a calculation correctly. So it's generally written as a three-step method, and all we're going to be doing is using the units algebraically. So that means that we're going to be multiplying units, we're going to be dividing units, and we're going to be cancelling units. So general process is this: you write the given quantity and its units on the left of the page, and then you write an equal sign, a space, and the wanted units on the right of the page. Then you're going to multiply your given quantity by one or more conversion factors, which, if you remember, are just fractions. And they're fractions that have the units that you want on the top line and the units that you don't want on the bottom line. And sometimes you have to multiply by multiple of these, but eventually it's going to lead you, when you cancel all the units out, to what you want. So then what you do is, before you actually put it into your calculator, you cancel units to make sure that you've got what you want, and then you enter it into your calculator. So let's have a look at what we mean. So this question says a tablet of aspirin contains 0.25 grams of aspirin. How many milligrams of aspirin does this tablet contain? So first step, write what you're given on the left, write what you want on the right. Now, we know that there are two conversion factors relating grams and milligrams. There's this guy, 1 milligram is the same as 10 to the minus 3 grams, or you could also write 10 to the minus 3 grams is the same as 1 milligram. Now, we want to get rid of grams, so we know that we need the 1 with grams on the bottom. So we're going to multiply by the one that has grams on the bottom. And you can see, I know I've got it right, because the units cancel out and leave just the milligrams behind. So now I'm going to do the multiplication in my calculator, and I'm going to get my answer. And you can see that I started with 3 significant figures, and I end with 3 significant figures, which makes sense because the quality of my measurement shouldn't change just because I modified the units. So here's another one. It says the length of my foot is 26 centimeters. Convert this to millimeters. So I've got 26 centimeters on the left, millimeters on the right, and I'm going to multiply it by one or more conversion factors. So a little trick is, when the thing that you're starting with and the thing that you're ending with both have a metric prefix, it's best to go through the base unit. So we're going to go from centimeters into the base unit meters, and then on to millimeters, and we'll have a conversion factor at each point. That wasn't very well written. There we go. Like so. Alright, so 26 centimeters times, and then we've got our divide sign, and then we want centimeters on the bottom. Boom. That gets us to meters, and then for meters we want to go into millimeters, so times 10 to minus 3 meters is the same as 1 millimeter. Meters cancels out, leaves me with millimeters. So I kind of know I've got it right. At this point, I'm kind of checking all my units before I put anything into my calculator. And so now I can go ahead and put it into my calculator. And 26 centimeters times 10 to the minus 2 meters per 1 centimeter times 1 millimeter per 10 to the minus 3 meters. You see that within your conversion factor, your unit, if it has an extra letter, it doesn't get a power of 10. If it doesn't have an extra letter, it gets the power of 10. Now, a millimeter is smaller than a centimeter, so we should get more millimeters than centimeters, which we do. We started with 2 sig figs. We end with 2 sig figs because trailing zeros don't count unless there's a decimal point within the number. Okay, so here's one involving a volume. And we have to be a little bit cautious with volumes and also with areas. So for a volume, you see that our unit here of length is cubed, right? And we have to go from, so this is talking about an Olympic swimming pool, we have to go from kilometers cubed to centimeters cubed. So these are my units that I'm starting with on the left. These are the units that I want to end up with on the right. And I notice that both have a prefix. So I'm going to go through the base unit. So this is going to go from kilometers cubed to meters cubed to centimeters cubed. Just like that, right? There it is there. Okay, so when my unit is cubed, I have to make sure that I cube my conversion factors. Very, very common error not to do that. Okay, otherwise things won't cancel. So 2.5 by 10 to the 6 kilometers cubed times, and I know there are 10 to the 3 meters in 1 kilometer, but I have to cube all of that because I've got to cancel out kilometers cubed. So that'll get me to meters cubed, and then I know that there are in 1 centimeter there are 10 to the minus 2 meters, but again I got to cube everything, and that'll get rid of my meters cubed, leaving me with centimeters cubed. So in this example, I've cubed the conversion factors at this intermediate step. You don't actually have to do that, right? You can just put it all into your calculator like that. Okay, I've just done that to kind of illustrate the point that the exponents won't cancel unless you cube your conversion factor. So finally, I've convinced myself that all my units cancel out and leave me with centimeters cubed, so I can go ahead and put it into my calculator. And you can see that there are many more centimeter cubes than there are kilometer cubes. So I'm feeling happy because a centimeter is like yay big and a kilometer is like, 2/3 of a mile. So we've done well. Right, here's another one, but in this case what we're doing is we're working in English units. So for many people, they'll need to look up tables of conversion factors for this. So we're asked to convert 20 fluid ounces, which is the size of a very large coffee, into gallons. So I'm expecting that I'm going to get, less than 20 gallons. Obviously my cup of coffee is not 20 gallons. So always good to check for logic in these things. So for 20 fluid ounces to gallons, what I know is that there are 32 fluid ounces in 1 quart and then 4 quarts in a gallon, but I don't know how many fluid ounces there are in a gallon. So I'm going to go this way, right? So 20 fluid ounces times, and in 1 quart there are 32 fluid ounces, and that gets me to quarts. And then I know that there are 4 quarts in 1 gallon, so I want quarts on the bottom to cancel out there, quarts. And then that's going to get me to gallons. So I'm pretty convinced that I got my problem set up correctly here. It's very clear to anybody that's reading it. And then when I do the math here, sure enough, I end up with a number that is a lot smaller than 20, which seems reasonable because a 20 fluid ounce, like I said, is just a large, very large coffee. And so it shouldn't be even 1 gallon, right? Okay, there's no way it's going to be a gallon. So something to keep in mind is that conversion factors between metric and English units are based off measurements. Somebody took a ruler that has markings on it every, in inches, every 1 inch perhaps, and then they measured that with a ruler that has markings on it in centimeters. Right. So they're based on measurements, they're not based on definitions. And so what that means is that these conversion factors have finite significant figures. So there'll always be a 1 in that conversion factor. That one is going to be treated as exact, and then this is where you're going to get your significant figures. I'm always going to give you any metric to English unit relationships that you need to complete your assignments, or in this case it's an online class, you can just look them up. Alright, so let's have a look at this. My best friend weighs 43 kilograms. Express this in pounds. So 1 pound is equal to 453.6 grams. So a pound is a little under half a kilogram. Right? So 43 kilograms, and we want to turn it into pounds. So what I'm going to do is use the information that's given to go from grams to pounds. So I'm going to need to get this into grams. So I'm going to go kilograms to grams, and then I'm going to use that information there to go from grams to pounds. Okay, so how do I go from kilograms to grams? Well, I have to multiply by the conversion factor that has kilograms on the bottom and grams on the top, and I know that there are 10 to the 3 grams in 1 kilogram. So now I'm here, and I got to go on to pounds. So I know that I need grams on the bottom for that to cancel out, and pounds on the top. And I know that there is 1 pound for every 453.6 grams. So that's going to leave me with what I want. So now I'm ready to go. I can just put everything into my calculator, and I know that it should be more pounds than kilograms. And there's a little, so in 1 pound there's about half a kilogram, so this should be a little over double, and it is. So we're feeling pretty happy about that. So 43 kilograms is 95 pounds, which isn't an unreasonable mass for a very small person. Okay, so this is one where we're going to do a volume conversion from metric units, or actually these are not metric units officially, right? Into cubic feet into English units. So 375 mils is the volume of a can of soda, and we're going to turn that into feet cubed. So the pathway that I would go is, and you might choose a different one, it doesn't matter, is milliliters to centimeters cubed. And then I'm going to use the information that I know about centimeters and inches to go from centimeters cubed to inch cubed. And then finally, I'm going to use the information I know about feet and inches to go from inch cubed to feet cubed. Now, 1 cubic foot is, a cube that is a foot on each side, 12 inches on each side, and a can of soda is not that big. So I know I'm going to get less than 1 cubic foot. So my answer at the end here is going to be less than 1. So keep that in mind as you work through this, right? So this is the key information to go from milliliters to centimeters cubed. Remember earlier we said that 1 centimeter cube is exactly the same as a milliliter. So there is 1 centimeter cube for every 1 milliliter. So that's easy. Okay. Now we're going to go from centimeters to inches. And I need to look up the conversion factor that relates these two quantities, because centimeters is metric and inches is English. And when I look that up, I see that there in 1 inch there are 2.54 centimeters, but remember I have to cube it. Right? I've got to cube my conversion factor or it doesn't work. Don't forget to do that. Okay. So then finally I'm going from inches to feet cubed. So I know that there are 12 inches in 1 foot, but again I got to remember to cube my conversion factor. So there we go. And so now I'm ready to put everything into my calculator, because I know the only units that I have left are feet cubed. So I put all of that in, and what do I get? I expanded out the conversion factors. You don't need to do that, but you can if you want to. I end up with 1.32 by 10 to the minus 2 feet cubed, which is less than 1, isn't it? It's 0.0132 feet cubed. So I started with 3 significant figures, I should end with 3 significant figures, and I do. So everything looks good and consistent. So a lot of units in chemistry involve more than one quantity combined together to give what you might call a complex unit. So a good example would be a speed contains units for both length and time, or a density, not a density, in this case it's a concentration, is containing units of amount, this time in terms of mass, in a given volume, right? So there's two things going on there, two base units within the one more complex unit. And you could convert either of those things. You could convert the miles to meters, and you could convert the hours to seconds, and then that would give you the speed in meters per second, right? In this case, you could turn the grams into pounds, and you could turn the liters into gallons, and you could get completely different units, right? So there are things that, there are multiple components that you could convert here, and sometimes there's 3 or 4 of these units. One of our favorite ones is this unit here, kilograms, meters squared, seconds squared. That comes up all the time. That's units for energy. Okay, so as I'm illustrating here, if you're going to convert miles per hour to meters per second, you're going to have to convert both a distance measurement and a time measurement. So here's an example. It says global emissions of carbon dioxide are estimated at 2 by 10 to the 9 tons per year. So that's mass, and that is time. So our unit is saying that we get 2 times 10 to the 9 tons of carbon dioxide for every 1 year. You see how we turn the per into this fraction? It becomes over 1. And we want to turn this into pounds per hour. So tons is going to get turned into pounds, and years are going to get turned into hours. Okay, so we're going to multiply by a conversion factor. The first one is going to have tons on the bottom and pounds on the top. You see in here, right? Tons leaves me with pounds. And now I got to deal with the years. So because I want to get rid of the years are going to have to go on the top, right? Because the years are down here now. So now I'm going to multiply I'm going to go from years to hours, but I'm going to do it in 2 steps. What I'm going to do is I'm going to go from years to days to hours. So as I was saying, the years are on the bottom, so I need my conversion factor needs the years on the top. And I'm going to go from years into days. And I know that there are 365.25 days in 1 year, and now my years will cancel out. Alright, so now I've got to get rid of my days, right? So again, because my days are on the bottom, I want my days on the top in my conversion factor, and I want my hours on the bottom here. And I know that in 1 day there are 24 hours, so now days are going to go, and the only units left over are pounds and hours. Alright, and there we are. When I put all of that into my calculator, and I started with 1 sig figs, so I've ended with 1 sig figs, I get I get a lot less pounds per hour than I do tons per year. So a little hard to visualize here because a pound is smaller than a ton, and an hour is a shorter period than a year. So you kind of got 2 things to kind of get your head around, but we end up with a smaller number, and that makes sense that there would be less pounds emitted per hour than there would be tons in a year. Alright, so In this case, we use 3 conversion factors. Our worst case scenario is 3 conversion factors. We never do more than 3 conversion factors in Chemistry 100. So let's have a look at a few. It says here, setting up a one-step conversion factor. And I'm going to convert from centimeters cubed to meters cubed. So how are centimeters and meters related? Well, centi means 10 to the minus 2. So 1 centimeter is equal to 10 to the minus 2 meters. So my conversion factor needs centimeters on the bottom and meters on the top, and it has to be cubed. There we go. So 24 centimeters cubed is going to get multiplied by the conversion factor 10 to the minus 2 meters or 1 centimeter, all cubed. And that will give me my units in meters cubed. So it says here, fill in the missing part of this equation. You're just going to fill in the blue box. You don't have to put in the question mark. Read the question clearly, alright? So there's no math to do here, so I won't pop up my calculator. Okay, so this one is about setting up a unit conversion, and it's the same deal. It says a student sets up the following equation to convert a measurement. Fill in the missing part of this equation, and then it gives you a little hint. It says, note your answer should be in the form of one or more fractions multiplied together. And so you are not expected to mathematically solve this. You're just meant to put in the missing conversion factors. So let's have a look at what changes and what doesn't change here. So pascals are units of pressure, and they're going to become kilopascals. And then we've got centimeters cubed, and they're going to become meters cubed. So this is all about decimal prefixes, right? So to go from pascals to kilopascals, I'm going to need some information about that. And so I know that 1 kilopascal is the same as 10 to the 3 pascals. Now this is squared, so I've got to be cubed, so I've got to be a little bit careful here, right? So how are centimeters and meters related? I know that 1 centimeter is the same as 10 to the minus 2 meters. So setting this up, minus 5.6 by 10 to the 4 pascals centimeters cubed. They're both on the top line, which kind of keeps it a little bit simpler. And so to go from pascals to kilopascals, I'm going to need pascals on the bottom, kilopascals on the top, and I get one of those for every 10 to the 3 of those. So I've done that bit. Alright. Okay, good. So now I got to do my centimeters cube business. So multiply. I want centimeters on the bottom, and I'm going to cube it before I even get going. And then I want meters on the top, and 1 centimeter cubed is the same as 10 to the minus 2 meters. And so centimeters cubed cancels because I've got the cube there. Pascals cancels, and then I'm left with kilopascals meters cubed, and I know I got it right. Okay, so not too bad, just more of the same. You don't actually have to evaluate it, you just had to write out what the 2 conversion factors were. Okay, so this one again, they're just asking you to set up the math for a one-step problem with a unit conversion. So you're just going to do this unit conversion, you're going to set the math up, but you're not actually going to do anything of it. All right? It says make sure your answer includes all the correct unit and symbols. So what's the problem? It says the speed of light is this. How far does light travel in 40 microseconds? So this is what I'm going to do. I'm going to make sure that everything has the same time unit. So I'm going to take my microseconds and I'm going to turn it into seconds. And then I'm going to multiply that by my meters per second, and you can see the seconds will drop out, and that'll give me meters. So I'll show you how to do this now. So what I need to know is how are microseconds and seconds related, and 1 microsecond is the same as 10 to the minus 6 seconds. So I'm going to do it this way: 4.0 microseconds times 10 to the minus 6 seconds in 1 microsecond, and then that would get me to seconds. And then finally I'm going to multiply by my 2.998. Let's just give me a bit of space here. 2.998 by 10 to the 8 meters for every 1 second. And you can see the microseconds cancel. The only unit left behind is meters. So it just says how far does it travel. It doesn't say that you have to give it in particular units. So this would just return it in meters, and if you wanted it in kilometers you could do another conversion, but it doesn't give you any preferred units for the length, so just keep it simple. Okay, so this section is just all about dimensional analysis and how we can use units to guide us in calculations, but also to help make it clear to other people how calculations are performed. You can see that in the ALEKS topics, the focus is on communicating how you're doing the calculation rather than doing the calculation itself. So you should be focusing on that as you work through this. Okay, if you have any difficulties, please just reach out to me. I'm here to help you.